I hope I'm audible to everyone. We will wait for some time for other students to join. Once they join, we will start the class. Yeah, we will start now. Uh, as we all, hello everyone. This is Rashi Art. I'm doing PhD in IIT Delhi, uh, under Professor Jayan Jain in Material Science and Department. Today, welcome back to week 6 interaction session on scanning electron ion probe microscopy and material characterization. The course has been taken by Devaprita Pradhan sir from IT Kharagpur in Material Science Center. Today I thought we'll start with an assignment and we will take the questions if anyone has any questions based on that. And as we all know, which of these statements is or correct for helium ion microscopy? Like helium ion microscopy, as we all know that we know ion will be used as a source. Ion will be used as a source, and then the helium ion as every time uh, helium ion. There are other ions also possible, barium, nitrogen ions, and argon ions, etc. All these ions also possible. And then number of secondary electron 1 is greater than a number of secondary electron 2. Yes, this statement is correct. Which of these statement is correct in helium ion microscopy? Number of secondary electron 1, that is the one which is falling as soon as it falls in the sample. The source, once again. As we all know, there is a source which is helium ions, and then the sample. When this falls on the sample, many secondary electron VIC and everything will be emitted, but the interaction volume where it will be having because of the helium ions will be very small compared to the interaction volume that will be forming because of electrons. And this the whatever the readings will be getting will be from the surface itself, topographical image only. So for each helium ions, for one helium ions, approximately around 8 to 7 to 8 secondary electron ions, secondary one electron ions will be produced. The BSc electrons which will be produced in this helium ions will be smaller compared to that of electron. So the helium ions produces more secondary electron 1 compared to Ac2, as you can see. So this statement is right. Number of Ac2 is greater than Ac1. No, the number of BAC electrons forming itself is lower in helium ions. So the Ac2 formation will be lower in the case of helium ions. Number of Ac2 per backscattered ions is smaller than the number of Ac1 unit per primary. This is a correct answer because number of Ac2 per backscattered ions forming, the backscattered ions will be present, but then the number of Ac2 will be forming per unit backscattered ions will be smaller compared to that of Ac1 per unit primary number. So this statement is correct, and then this statement is correct. These two statements will be right. So electron generated from primary ions, and then both Ac1 and Ac2 are high. This is not true. Only Ac1 is higher. So the correct answer is number of Ac1 is greater than Ac2. Number of Ac2 per backscattered ion is smaller than the number of Ac1 per unit primary ions. Detailed answer is that the electron generated from primary ion B interaction with the sample is called Sc1, as I told. These are much higher than Se2 generated by backscatter ion. Moreover, number of Se1 is much larger because high energy primary ions as compared to that of backscattered ions. Here is to show that, as you know, this is a helium ion. Helium ion beam. As soon as it interacts with the sample, the secondary, as soon as it forms the secondary electrons, one, these are higher in number compared to BAC because the BAC forming the because the interaction volume for the helium ions will be smaller. In addition to that, BAC from BAC, not BAC, backscattered ion formation will be backscattered ion will be formation will be very smaller because the ion mass of the ion is larger. So it cannot penetrate more deeper to create a higher backscattered ion, and then further this cannot produce more Se2 ions. So the presence of Se2 is the one of the main factors limiting the spatial resolution. Exactly, right? Because every time what it happens, backscattered electron or backscattered ion, whatever it can be, it goes inside the sample. Here it goes inside the sample, and then it creates an interaction again, and then it forms Se2. This Se2 will reduce the spatial resolution formation because it will be coming from the deeper, little bit deeper from the sample surface, and then it will not give. It will keep on producing because more number of collision will be keep on happening, and then it will be coming from the deeper. That's why the presence of Se2 is one of the main factor limiting the spatial resolution in SEM. So HIM, because Se2 escapes from the region defined by the width, because of that Se2 escapes from the region defined by the width of interaction volume. Width of interaction volume. In general, Se2 by Se1 ratio depends on the specimen material and ion energy. But in general, Se1 will be having higher number in helium ion compared to Se2. The number of Se2 per unit path of backscattered ion is less than the number of Se1 per unit path of primary ion. When energy of the primary ion increases, BSI energy also increases. Yes, but then even though BSI energy increases, the mass of the ion, the helium ion, will be higher compared to that of the electron. So the penetration will not be that deeper when compared to the electron. And then the backscattering energy it also increases as we increase the primary ion energy, but then later on, the further collision inside the material will be difficult, and then the production Se2 production will be lower. So Se2 to Se1 ratio in helium ion beam will be lower compared to that of electron in samples. So coming to second question, only SET can be collected and detected by detector in HIM by dash. So for this, before that we will go to SE3 how yield is done. So as we all know, first one second. So as you all know, so as you all know, when a beam will be falling on the sample, ion beam, or it can be an electron beam, for that matter, and then the sample is there. So when it interacts, as soon as it falls on the sample, during the interaction, whatever it comes out is a secondary electron 1, Se1. These, as soon as the interaction, the a beam gets interacted with the sample, whatever is produced is Se1. As we all know, the ion will not only produce secondary electron, further other signals also will be produced. One among the signal is BAC1, BAC, backscattered electrons or backscattered ions. So when these backscattered ions will produce inside a sample, this will further produce, this pollution will further produce, this backscatter will further pollution will further produce secondary electrons. These secondary electrons are named as Se2, secondary electron 2. And then further there will be a detector here present, detector present. So this Se2 goes and then hits and then produces again further secondary electrons. These are known as Se3. So this is the case in case of ion or electron beam. So only Se3 electrons can be collected. So these electrons will be in order to collect these electrons, you have to apply a negative voltage to the grid by applying negative voltage to the grid above the sample and applying these electrons will be produced here, C3, and then we have to apply a grid here. In order to collect the Se3, it should be in negative, we should apply negative voltage, negative potential. So it shows that by putting the grid above the sample and applying positive voltage will not allow us to collect the Se3 electrons. By putting the grid above the sample by applying negative voltage. Usually, sir has even mentioned that it can be minus 50 EV. So up to minus 50, anything is fine. Like it should be negative. By applying negative voltage for the sample, no, nothing is going to happen to collect the Se3 electrons. Even if you apply for the detector, nothing is going to happen. You have to apply a grid above the sample, just above the sample, and you have to apply it in negative potential. The energy of secondary electron is generally 5 to 10 electron volt, and thus stopped rejected by the grid at minus 10 above the sample. On the other hand, high energy backscattered ions can easily pass through the grid and strike the lens, pole pieces, and wall of the chamber to produce Se3 to be collected by the detector. Correct. So Se3 will be detected here by applying when it hits the objective lens, and then will be detected by detector by applying the negative voltage. So the yield of PAC is in the range of 0.1 to 0.5. Yeah, this is the case which I wanted to discuss. One more thing. In the PAC, yield will be higher in case of electrons when electron is used as an source compared to ion. However, the in BSI the yield will be very low, 0.01 to zero point 0.2, which is a wide range as sir has also mentioned. And then this will not provide us the enough secondary electron to so that is like Se1 and Se3. This has a strong consequences in the yield of Se3. So moreover, and secondary SBI yield in crystalline metal is strongly affected by channeling than the outflow of electrons. So number of electrons that is hitting, number of ions that are hitting the detector, the backscatter electrons, backscatter ions will depend. That will be depending on the Se3 yield. So coming to question 3. So I will give you some time to solve this question. Um, which of the following ions could provide surface information or surface contrast? The hint is here. Which of the following ions? Which of the following ions could provide maximum surface information or contrast? As you all know, I want to discuss one more thing. So there are several contrast mechanism. One is a topographical, which will give like in helium ion microscopy. One is topographic contrast. Second is material or compositional contrast. Ion channeling contrast, voltage contrast, magnetic contrast, optical contrast, and then ion optical contrast. So, as topographical contrast, as you all know, that how if the features are having some like ups and downs on the surface, then whether we are able to see the surface features or not is what is topographical contrast will be. How? And in material contrast, if there is some deposition here, and then if there is some deposition here, is it this is a deposition of, consider AU, this is a deposition of AG. Is it able to differentiate the deposition? Is it able to give the contrast of these two samples? Is not or not is the material contrast and ion channeling, and these two contrasts we will talk right now. In this, there are other contrasts because of voltage and magnetic and optical and ion channeling. The contrast can be different. So, which of the following provides surface information or surface contrast? Like nitrogen ions which are present will give the highest contrast because it has a small depth of penetration, and thus the signals coming from the surface are only near the surface. That's all. So in helium, what happens compared to others? This one has um, nitrogen has a smaller um, depth of penetration. Like what happens is that first thing, helium, when we bombard the sample, when we expose the sample for helium, we will consider, and we are exposing another one for nitrogen, helium and nitrogen. When it is exposed with an helium, the interaction volume will be very small. But in the case of nitrogen, here the interaction or volume also will be little bit higher. Here the depth of penetration will be smaller compared to that of helium. But then what nitrogen does is that it destroys the sample because the nitrogen will be having high energy compared to that of helium, and then it will be destroying, even though it has small depth of penetration, it will destroy the sample that is present, that is exposed. And if this area has been exposed, it will destroy this much sample, and it will give the better contrast. But when you zoom out the sample, then you'll be having the different contrast because of beam damage, because of nitrogen ion beam exposed to the sample exposure, it gets damaged. The damage is minimum in the case of helium compared to that of nitrogen. So that's the reason why like helium is used more compared to that of nitrogen, even though it gives a better contrast difference, surface contrast difference, and surface information difference. So yes, it's a nitrogen is the best thing to give the surface information or surface contrast, but then helium is better because it gives the surface damage less. So this is an example which I was telling before, like to give, as you can see that when depending on how much energy the mm, uh, ion beam has, it will have, see, there is one order difference. The contrast will vary depending on that. But then for the same, if you consider the similar energy, the contrast is not that better in case of helium compared to that of nitrogen. Yeah, you can see, and if you have any doubt, you can ask. So the as you can see that There will be a difference in contrast in nitrogen when nitrogen ion is used compared to that of helium ion. And then for the similar, as here you can see that it is here it's a graphite, and this is graphite, and this is graphene. And when you use the higher, even more higher, there is no much contrast difference seen between graphite and graphene. But then in the case of nitrogen ion, it is very well seen. But then what nitrogen does is that it destroys the sample, and then will not, like, it destroys the sample because it will be having smaller, even though it has smaller depth of smaller penetration depth, it will be having higher energy, and then it will destroy the sample compared to that of helium ion destruction possible. And coming to next question, which of the following signal is best preferred for insulating samples in HM? And solve this question, I'll give you a couple of minutes, and please tell me the reason. One second. So, which of the signal is best performed in insulator sample in helium ion microscopy? So, as we all know, if the sample is non-conductor, if the sample is non-conductor, then when a beam falls on the sample, when a beam falls on the sample, there will be charging up happening, whether it can be electron or ion microscopy, electron or ion beam. So because it will not be a conductor, it charge will electron the charge buildup will happen on the surface. So when you take a backscattered electron, then it is least affected by the charging issue, like or any other any other effects like electron or ion building up on the sample. So in SE1, what happens when sample falls, when beam falls on the sample, if there is any other ion or electrons charged up on the sample, this SE1 will not be having further, it will not be coming out properly, or it will not be able to penetrate, the ion will not be further able to penetrate properly, and then it will be giving brighter and some places will be brighter and some places will be darker. And the same goes for Se2, but Se2, as you can know that backscattered ions are the main responsible for creating Se2. Similarly, when Se3, but then for the insulator samples, the best will be backscattered ions. As you all know, the energy of the backscatter ions are high. They are least affected by the surface charge of insulating sample. So in transmission ion, in the scanning transmission ion microscopy, strike gold-coated silicon wafer tilted at a dash angle. For this, uh, I'll show you an image where, as you all know, that scanning and transmission ion microscopy is similar to that of which is TEM or scanning transmission electron microscopy. It will be having some angle here present here compared to that of gold. Like here is gold coated. Here is where the sun surface is kept. As you can see, it is kept at 45 degree to the detector to have a better to get the better signal in the detector. That's the reason. So as you can see, it is kept at 45 degree. So the answer is 45. Transmission ions come after passing through the sample. Yes. So when sample is kept, consider this sample, the thickness of the sample should be as minimum, as very small, in such a way that when ion falls on the sample, it gets transmitted through the sample. It is not that easy to transmit the ions through the sample because the size of the ion and then the mass of the ion is very high compared to that of mass of the ions are very high compared to that of electrons. The mass is very low. This is the best part for creating like secondary electrons. This helps, but then for transmitting through the sample or through any substance, the mass of the ion mass of the being should be very small. That's why the electrons will be able to penetrate and transmit through the sample easily compared to that of mass of ions. That's why transmission ion microscopy, scanning transmission ion microscopy is not that mostly used in any industry compared to that of electron. In HIM, microanalysis with backscattered ions is not preferred for. Uh, for this, I'll be showing you two images. I want you guys to get like process the question, and then I'll be teaching it properly later. In HIM, microanalysis for backscattered ion is not preferred for. Let's discuss this in detail now, one by one. As you all know, the signal of backscattered electron depends upon difference in the as you all know, the signal of the backscattered electron will depend upon the I'll show you a video and depend upon the how much energy you are getting, depends upon the difference in helium atom and then atomic weight and then the target atomic weight. So with initially what happens, the difference will be very good, and then BAC signals will be getting good, better. If the difference is higher and with the lower atomic weight, they will be getting the contrast difference will be very high. And as you go on with higher atomic number, what happens, the contrast between two different atoms, if it is chromium or iron or like molybdenum or what is this, silver, these two, if they are present in the microstructure, if this is a microstructure and it has a layer of molybdenum and it has a layer of uh, silver, then it will not be showing much contrast difference, because with increasing the atomic weight, the contrast difference which will be happening will be lower. That's why, that is one of the reason why the contrast will not be seen better in helium ion microscopy, because that depends upon the difference in atomic weight of the helium and then that of the element which you are seeing. And also it depends upon the sample thickness. With increasing the size, if the sample thickness is very small, if the say small thin sample is there, thin, and then the sample is a little bit thicker, so when helium ion falls on the sample, it gets interacted and then trapped inside the sample, and then it will be creating the signal further. And then if it is a thin sample, it will not create much of the signals or disturbance. When if the sample thickness is very high, what it does is goes further and then further it gets disturbed, and then it will be disturbing as with increasing the thickness of the sample, it will be further disturbing, and then it will be getting the signals different. So with increasing the sample thickness, as you can see that for 3 nanometer, this is the variation that we are getting very nice peaks of difference in, but if you increase the sample thickness, it's not only kind of merging the peaks present, but it also widening the peaks present. Peak widening is happening. So this is mainly because that it further, and then the resolution of the peaks will not be better, and you're not able to read the data better if the sample thickness is very high. So in microanalysis with backscattered ions is not preferred for having higher atomic number material and the thick sample. This is mainly, you can see that the energy of backscattered ions generated from higher atomic number material are very close to be distinguished and not for following linear fashion. As I showed, it increases drastically with increasing the atomic number. That's why will not be able to resolve or see the contrast, well, not resolve, see the contrast very well at higher atomic number. Moreover, energy of backscattered ions depends on the thickness of the specimen. Thus, the microanalysis with backscattered ions in HIM is not preferred. In secondary ion spectroscopy, that is secondary ion mass spectroscopy, SIMS, The ion is extracted using dash. Like you try to solve this problem as we will go in detail later. I'm just checking if any of the people are like there in the group. mentioning that in secondary ion mass spectroscopy, an energetic beam of ions for primary ions is used to sputter the sample. So as soon as the sample, the primary beams is used, primary beam in the sample is used, what it does, as soon as it falls in the sample, it sputters the sample. It will remove the sample. The primary ions penetrate the target and lose all or part of their energy during the collision cascades with the target. Some of these collision cascades will lead to ejection of one or several target atoms amongst the emitted particles. Ions called secondary ions, which we are interested in, is called SIMS, secondary ion mass spectroscopy. These ions are extracted using electric field and accelerated into mass spectroscopy, mass filtered and counted by the detector. It is important to note that atoms are mainly sputtered from the topmost monolayer. So as you can see that in secondary ions, the ion is extracted using electric field, uh, not the magnetic field or not electromagnetic field or not ions are already present. The electric field is used to collect the secondary ions generated from the specimen. Sputtering of material with high yield is preferred using dash ions. Give a fair guess and then we will discuss using this one. Hello, Ajit. Ajit, do you have any questions to discuss?
Uh, so, uh,
Hello.
Hello.
Hi Ajit. You have any questions to discuss?
I not now. No.
Because we started actually class sooner today. I started from 5 o'clock. I
Okay.
completed the assignment. It was just I was discussing the assignment only because I had a little bit work later.
Okay.
Uh, so I thought like I'll wait till 7. If you have any questions, we can discuss. So you'll be writing an exam, Ajit, for this.
Yes.
Hello. When is the exam, by the way?
I think it's 29th of April.
29th February. 29th
April.
April. Okay. 25th the class will end. So how is the preparation going on?
I think exam online. I think online exam maybe
No, I don't
MCQ.
think the exam is online.
I think I have get a email.
Huh?
Uh, uh, an hour earlier, I got an alert, an email
Huh?
regarding type of examination. So there are two modes: offline mode and online. I think this course is on online mode. So in online mode, I think MCQ type, filling the blank type, and I think some comprehensive essay type questions will
Okay.
be there. Yeah.
Oh, that's it. Nice.
Yeah.
So how is the preparation going on? Fine then.
Sorry, pardon, please.
Preparation going on. Is it fine? Preparation.
Yeah, preparation is it fine? Okay, yeah.
So you
Yes.
took any other courses in NPTL or this was the only course which you took?
I think I have taken early some of the courses, but I think it's exam for first time now. I have registered for exam first time.
Okay, okay, okay. You simply used to take the class but not like attend the exam.
Yeah.
Okay, 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 fine. So if you don't have any question, it's fine only. I don't have anything to teach actually. Like I was just waiting for like everyone to come and I started at 5. I thought of completing it like sooner only.
Okay, no problem. Fine for me.
By the way, you were asking about one thing, right? Did you get the results? Like did you try EPMA?
Pardon, please. I think there is some.
You Acha, okay. Did you try EPMA? EPMA.
No, EPM may not till. Not yet.
So which one will you will be using then?
Uh, Actually, I'm using just FSM and
FESM only. That
yeah,
is easily available. No, EPMA is a little bit difficult, correct? Huh?
yes, actually,
But in
and
IT Delhi, you can actually book from outside also, and you can send the samples. They will do the sample analysis and then send you the results actually.
okay. Actually, I think I have go through the. I have not found your email address.
My email address. Whose email address?
Yeah, I think in somewhere
Okay.
in dis yeah, in discussion
What
form.
about the Sims, by the way? Did you try Sims?
Pardon, please.
Sims. No.
Uh, Actually, I am not able to hear you
Oh,
rightly.
okay. I actually changed the location today. I don't know whether it. I think so. That's network issue is there a bit. I think right. You're not able to listen to me properly. I'll just change the location. Are you able to hear me now properly?
Hello.
Are you able to hear me properly now?
Uh, Wait, please wait.
You're able to hear me properly now?
Yeah, right now.
Uh, so what you were telling?
Uh,
Mass spectroscopy that secondary ion mass spectroscopy SIMS was there, no? I was talking about that. Did you ever think of doing SIMS for your samples?
Mass spectroscopy.
Mm.
Actually, I think I have no idea about mass spectroscopies.
Secondary ion mass spectroscopy, sir has taught in week 5, I guess. Uh,
Okay,
when
okay, yeah, got,
uh,
got, got. Yes,
so
yeah.
that also you can do for your samples, no SIMS.
Okay, okay, okay.
You just read about it. I think you have to like so just go through how are you getting the marks in assignment? It's fine.
Mark is consistent, I think, 70, 80, 100, 95.
Mm. Yeah. And do you want to discuss anything else, or you want me to discuss anything in the next class?
Actually, this week, actually, I'm not able to devote most of the time.
Uh,
So,
So I what I'll do, I'll give a summary of the whole class. Next week I'll do that. Complete class week 6, whichever I have taken, like sir has thought, I'll try to give 1 hour for that, and then 1 more hour I'll discuss the assignment. Then will that be fine?
yeah, it's fine.
I'll do that. Like week 5, I did the preparation today. Like if you want, I can discuss. We can go through the slides also.
Yeah, okay.
So I'll just explain it. I'll try to explain it to you in 10-15 minutes as much as possible. Sure. So in this, sir was telling about SE2 and SE1. You do remember this one, right? This is a week 5 class. This is about scanning. Ion microscopy.
Yeah,
Uh, So this is about scanning ion microscopy. And then he was trying to tell in this part, like when ions will fall on the sample, right? As we all know that as soon as sample ion beam falls on the sample, first whatever we will get, right, that is secondary electron one, right?
yes,
And what will happen? This ion will further go. It will have an interaction volume. In case of uh, helium ions, the interaction volume will be smaller compared to that of electron. When you seek electron, the interaction volume will be bigger. That is the difference between helium and electron. In helium, that is the main reason why you get the topographical images, the surface images properly compared to that of say, electron beam, because electron beam, it further goes inside the sample and then it forms BAC images. Mm, okay. You mute yours. Okay, so this will further go and then produce BAC signals, and then these signals will further, what it will be having, it will collide further inside the sample BAC images and the BAC signals, and then forms the secondary SE2 signals. Okay, and you understood the difference between SE1, SE2, and SE3, right?
Yeah.
So SE2 signals which will be coming because of these SE2, because it is coming from the subsurface, right? This will not be able to give proper spatial resolution on the surface, but that is not the case in case of ion beam. This will only, we will be only getting the surface features only, not from inside the sample. And then BAC image, and as we all know, ion, that is helium ion will be having higher mass compared to that of electrons, and then this will be penetration capacity will be having lesser. Even though the energy of this one is better, the penetration capacity will be lesser, and this will only produce, as soon as it interacts with the sample surface, it will produce around 7 to 8 Se1 compared to that of electron. One electron will produce only one or two secondary electrons, but in case of helium, secondary electrons production will be around 7 to 8, that is higher compared to that of electrons. That's why usually on the for finding out the topographical images, secondary electrons for helium ion is better compare. If you want to see the compositional analysis and all those things, for those things, normal electron beam is used. That is the main difference between electron and then ion beam. How to differentiate? If you want to see the topographical images, then you have to go for helium, I mean, or sorry, ion microscopy. If you want to see the here surface images, which is metal and it is conductor and we don't need any coating, and then you have to see the compositional difference and all, then you have to go for electron. And then because of this main reason, the SE2 signals formation will be lower, because BAC signals will be lower in case of ion compared to that of SE1. So, and SE1 ratio will be is number of SE1 will producing will be higher compared to that of SE2. This is what this whole point is, sir was trying to explain in this one. And in next, in SE3 also, as you know, how SE3 are produced, right? When backscattered electrons are produced, it goes and it's the objective lens present, and this further produces secondary electron. So secondary electron, if BAC electrons itself is very low, then the SE3 yield will be very less. That is what he was trying to tell, that SE3 formation will be lower. You can, as you know, the yield of Se3 is very small in case of ion compared to that of electron. The yield, as you can see, is very high compared to this. So that's why Se3 yield will be more in case of electrons compared to that of ion. That is what he was trying to tell. And he was trying here in this slide, he was trying to explain how backscattered ion and second Se3, if you use with Se3, there is no much difference, right? Here from here to here. But only if secondary electron was you're trying to see, then you will not be able to see much contrast difference. That is what he was trying to explain here, like here. And then beam damage. Because of helium which we use, the beam compared to helium, other ion sources are also present. That will cause the surface sample damage more compared to that of helium. That one thing you have to keep in mind. Other, especially nitrogen, even though it gives a better contrast, but the surface damage, sample damage will be higher in case of nitrogen compared to helium. And then here helium, in case of helium, the damage is very small. That because the interaction volume is also very small, and the signals will be getting only from the surface. That's why we'll be having highest resolution and then larger depth of field, and we'll be able to see it in 3D type of image with better contrast. Though we cannot go as is saying, it causes sample at the surface because of larger mass. And then BAC mode, it's not usually preferred for ion actually. And there are, you have to remember this one for sure. There are different type of contrast mechanism, like topographical contrast because of variation in the sample surface height, and this one, and then material and other whether if higher element. And as you all know, I mean, as you know, um, one thing was there, right? No, not in this lecture. It is there in another lecture. Okay, I will. Mm, this if any other element is present, if the element atomic number is lower, then the contrast between the lower atomic number will be very high, as you because as sir, it will be like this, right? Lower atomic number, and then it higher atomic number contrast you will be able to see very small. I think so. It is there in the next lecture. I'll be showing that properly. If the atomic number in ion microscopy, what will happen if in especially helium ion microscopy, what will happen if the atomic number is lower, then the contrast will be better. But as you go higher atomic number, the contrast between two different atomic number will not be showing much difference. This is because the difference, it should be that depends upon the atomic number of helium to the energies of the atomic number of the sample present in the sample. So at lower atomic number, the difference will be higher, and then you'll be able to see the contrast difference better compared to that of higher atomic number. So you have to try to remember this contrast mechanism. Like, and this probably is one of the important thing that you have to know: topographical contrast, how it is, and all about all these things. This you, I think sir has explained better. When you use 15 kV, you will be getting the information from lower sample, like from subsurface also. When you use only the very low kV, then you are able to get only in the surface. But when you use higher kV, then you are able to get proper topographical image. And then he was trying to differentiate between HIM and then SEM. And you can see that this was taken in BAC mode, I guess, if sir was telling, if I'm not wrong. As you can see, the contrast is not much, but then here the contrast is seen. This is SE mode only, I guess, or BAC. I don't know exactly. I forgot which mode was that. And he was trying to explain that there is no, the contrast is very high here, and then here you can see that 3D type of image will be present because this is BAC mode only. This is mainly because in SEM we will be able to get better contrast difference and when that number is varied. Mm, so scattered image. Uh, when the same sample, when they try to do it in normal SE mode, and then when they try to do it in BAC mode, in SE mode you can see, we can see that there is some variation in that's it, but then you will not be able to see obviously the much contrast difference will not be seen, and then which element is present you'll not be able to see properly. So when you try to do ion imaging with backscattered electron, you will be able to see the difference in contrast, similar to the one which happens in electron image also, electron. You cannot, if you, especially if you want to see the BAC image, right? It's always better to rely on secondary electron, electron beam compared to that of ion beam, because as you see that not all ions are same, but not all the electrons are same. As you can see that nitrogen ions will give the better, in one of the samples that has shown. Mm, yeah, nitrogen will be showing the better contrast compared to that of helium ion. So that's why you have to see, like, for finding getting the BAC image. No, it is always better if you try and get it in a secondary, SEM mode. Ion electron beam, not ion beam. Um, that is one point. Mm, and as I was telling, the beam damage will happen in case of nitrogen ion microscope compared to that of helium, because even though the interaction volume, the smaller depth, penetration depth is happening in nitrogen, but then it will destroy the sample because it will be having higher energy compared to that of helium. And then you'll not be able to, you cannot relate the contrast difference between, you cannot compare nitrogen ion to helium ion. And then if you use a nitrogen, you will get the better contrast, but then you will not be having, sample damage will be very high compared to that of helium. But when you use helium, the contrast is not very good. So when you want to go for BAC image, go always for electron image, electron mode, electron beam. And and this is one of the best part, like in helium ion microscopy, is that you will be having higher depth of field, that you can only get in secondary image. When secondary imaging is required, especially for the insulators or insulator. If it is insulator, you have to go for BAC mode, because the insulator will have less problem in with charging issue. But then this one, further. Depth of field will be better in case of HIM, because it will be having secondary electrons coming, many electrons coming. Hello, Ajit. I don't know you left. Hello.
Hello. Sorry, I think there is some glitch between.
No, 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 it's fine. I'll do one thing. I'll keep the slides properly for next class. I'll put everything together, and like we will revise from the beginning.
Okay.
When I have to go now, actually, I started at 5 only. So,
Okay.
it's okay only. I was, I'll next class we'll try to skim up with all the lectures sir has taught till week 6. We will can do it. Okay, we'll not solve the assignment problems and all. We will do this. Okay.
Okay.
Okay, Ajit. Bye.
Thank you.